Hello, and welcome to today's AWS webinar, Journey Through the Cloud. Today we're discussing managing your cloud assets, and my name's Ryan Shuttleworth, and I'm a technical evangelist at AWS, and I'll be taking you through the agenda today. So the Journey Through the Cloud series is all about taking you through some common use cases and stepping stones into the AWS cloud, where you can learn from the common points in the journey that other customers have experienced and what they've done and how they've learned, so that you can get best practices to bootstrap your projects and help you along your journey into the cloud. And today's is all about managing your cloud assets and really getting to grips with system sprawl that can occur in an unconstrained environment like AWS, where you can tap into unlimited potential resources. Then you can find yourself in a situation where you have resources in the cloud and you're struggling to manage those assets. I'm going to look at how you can leverage some management frameworks in order to take control over those assets, and ultimately help you choose some systems in AWS that suit your technology delivery style. So whether you be a developer-centric organization or an operations-centric organization, we can give you some ideas of how you can get to grips with those toolings. So the agenda, I'm going to start by setting the scene and talk about a spectrum, if you like, of approaches to managing assets in the cloud. And then at one end of that spectrum, we'll look at a shrink-wrapped approach using Elastic Beanstalk, our application framework management platform in AWS. The other end of the spectrum, we'll talk about fine-grained control, asserting declarative control using CloudFormation templating. And then we'll introduce the new Opsworks framework, which really sits in the middle of those two approaches. So setting the scene, and why is this sort of sprawl of resources occurring more in the cloud than would do in traditional facilities? And I think it's driven really the fact that cloud assets are growing quickly because we're defining more and more architectural patterns for the use of cloud. And certainly if you go to aws.amazon.com/architecture, you'll find a whole range of those driving things from batch processing, web apps, highly fault tolerant, highly available application deployments. And as a result, more applications are being deployed, more data is resident in the cloud, and that itself has a certain gravity associated to it, so it's easier to move applications towards the data, and as a result you end up having more services in the cloud. And the cloud fundamentally gives you greater agility, so these environments tend to be much faster moving as a result. They tend to iterate more, you tend to get more versions of things going up, you tend to take more agile approaches with the assets you have in the cloud. And all of that means that cloud assets are growing quickly and you need a way to control it that you wouldn't have had, or it's an order of magnitude more complicated or diverse the problem that you have in the cloud versus a constrained physical on-premise facility. So how do you maintain control over what is deployed in the cloud? And as I mentioned, I'm going to talk about two ends of a spectrum. And I like to think of those ends of the spectrum as being one end is about controlled chaos, and the other end of that spectrum being meticulous management. So you think about a spectrum of ways in which you would manage your environment in order to get control of the chaos that might be occurring versus how you meticulously manage every moving part of an environment. So what do I mean by controlled chaos? Well, if you think about what might happen in a developer-centric, a small developer team, light on resources, that you might prototype an app and then you deploy it to an instance. You go straight into a bunch of test and dev cycles, and then that instance probably gets promoted into production when you're ready and happy. You might then deploy more instances from it, from AMIs, for example, get to the point of needing RDS databases, deploy those, stick load balancers across the top, and then maybe add auto-scaling and start flushing instances out into auto-scaling groups. And then you might take a breath and sit back and say, well, what is it do I actually have in my environment? And it can quickly become a developer or DevOps nightmare when you have small teams, and particularly when you're running at a very fast pace of development or innovation, you can get out of control. So that's what I call about sort of controlled chaos. At the other end of the spectrum, we have meticulous management, and the approach here might be much more formal in terms of you prototype an app, and off the back of that you plan the infrastructure required, implement some build and deployment standards and deploy those environments, manage things through change control, implement formal processes, wrap in formal tools, maybe using things like Chef Puppet to do that, to create something that's quite tightly controlled and efficient and automated, but can be a lot of effort to achieve. Okay, so two ends of the spectrum. And the things that really help you move between these two ends, or control where you sit upon that spectrum, are fundamentally your people. Your people are your best assets. They're what make your tools sing for you. But you also have processes and controls. So whether you have strict processes or informal processes in terms of how you manage your deployments or your application assets, whether you have tight security controls maybe around what you can and cannot do, or authorization controls because you're having to adhere to some sort of external audited standard versus loose controls. And of course, the tools that you have form an essential part in supporting your people, your processes, and implementing those controls. And it's those tools that we'll have a look at today. And if you think about what we mean then by, or the desires of how the tools that we want for controlling chaos, I think of it as managing at a high level a shrink-wrapped app. And the tools that we want in that space, that's what we're after. We're after something that's going to manage the assets that we deploy underneath an application, so that if I'm iterating fast on an application, I know the infrastructure below is taken care of. Because ultimately it might be that I just want my app to run and I only want access to those machines if I really need to, versus the meticulous management where we're looking for fine-grained declarative control over the assets that are created in the cloud. So you might have a philosophy or a desire where you want to source control the entire virtual data center, just like you would an Apache config or a piece of code, so that you can create an environment that's tightly controlled and auditable. And the tools that we have, the frameworks that we have that enable you to do that, one end we have Elastic Beanstalk, the other end we have CloudFormation, and we'll look at both of those in turn today. But recently we also released a middle ground framework, if you like, and this is AWS Opsworks, where really we're enabling people to interact with a level of abstraction away from AWS resources that you can achieve with Beanstalk in terms of managing layers of an application, but you can also dive down into the fine-grained detail and get declarative control through that framework using things like Chef. So the middle ground, AWS Opsworks, we'll also look at last today, that gives you a bit of both worlds and maybe helps you along that sort of spectrum. So the first one we'll look at today is Elastic Beanstalk. So Elastic Beanstalk is summarized by this graphic. And Elastic Beanstalk is all about taking an application version, the cubes at the top, and managing their deployments into an environment down the black boxes at the right. So there I've got two environments. I've got test environment and I've got production environment. And each of those environments has differences. So one has different instance sizes, we have different auto-scaling properties, one is single availability zone, one is multi-availability zone. And one is using a test database and one is using a production database. And Beanstalk is all about taking an application version of some sort of code and deploying it into a managed application environment that adheres to all the best practice architectural principles that AWS talks about. Now, obviously, if you're going to deploy an application, you need to know what sort of container it's going to run in, so therefore you can choose what code to write in or match it to what you're doing today. And the range of containers that Beanstalk supports are .NET, PHP, Java, Python, Ruby, and Node.js. And we're adding new containers all the time. So there's a really great place that you can keep updated on this, and this applies to all of the services inside AWS. If you take an RSS feed from aws.typepad.com, my colleague Jeff in the States will blog regularly as new features, new services are released and updated, and that's the gospel truth of where you can get details of the up-to-date releases. And every morning in your inbox you'll get a blog article talking about some new things going on in AWS. So back to Beanstalk then, in terms of this web application package of some sort, whether it be a .NET package, whether it be a PHP application and so on, deploying that into a Beanstalk, what actually goes on under the covers? Well, if you think about the container itself, as a generalized view of the container, there's the user application that you're deploying on top that's ultimately going to run on an EC2 host at the bottom, and then the stuff in between is what's managed by Beanstalk. So we have an application service, we're going to have some sort of HTTP handler for a web app, some sort of language interpreter so that's going to support the type of application that you're deploying at the top, and it's going to sit on an operating system, either Linux or Windows, and then that's going to be deployed onto an EC2 instance in order to run. And that's what would be a managed, if you like, container inside Beanstalk. So looking at how the Beanstalk environment is managed around those EC2 containers, the first thing that we can look at that's deployed by Beanstalk is an Elastic Load Balancer. Because we're going to spread these containers across ultimately a group of resources under auto-scaling, we're going to need some way of load balancing the web requests across the top. So Elastic Load Balancers are created, and behind those we'll create an auto-scaling group defined to your properties. So we could have, for example, a minimum of 2, maximum of 10 defined in the Beanstalk definition. And then within that auto-scaling group, we'll push those EC2 instances that are running the container of your choice and have your application deployed to it. So here I've got 2 instances created in that auto-scaling group. And then we'll wire that up into the Beanstalk framework, and then we'll publish that under a CNAME so that you can map that DNS name so that you can route web requests to it. So ultimately, HTTP requests will come in, they'll hit the Elastic Load Balancer, be load balanced across your containers running on EC2 instances, and we'll get the response back to your users. With logs, we also consolidate from those EC2 instances into S3. So shown here is a diagram where I have my logs from all the application containers pushed out into S3, and you can view those via the console, or I can go and access those buckets directly. But we also store the file versions, the application versions that you're deploying in S3. So you can stack up different versions of an app via the console, and then you can choose to deploy that app or roll back that app. And then we'll push that container, that code to the containers across your EC2 instances, and we'll do a seamless rollout with 0 downtime. If you look at that container then for different languages, they differ depending upon the language, and we try to choose the most industry standard and high performance configurations that we can, that are widely supported stuff. So take Python for example, we're using mod WSGI to hook up the Apache HTTP interpreter to the Python language, so commonly accepted as the best way of doing that. For Ruby we're using Nginx and Passenger, so a common Ruby setup for Rails applications. So you can see that the containers differ slightly depending on what we're deploying, and of course the hosts will differ. If we're deploying a .NET application, it will be a Windows host. But what about the data? So I've deployed an application here, and okay, I can deploy a web server and a web tier, but why can't I, where's my relational database platform behind the scenes, which is what you're going to need typically. So if you look at deploying an application, such as a Ruby Rails application or a Python Django, these applications contain models. So you define in your code your classes, they generate a relational model under covers, and then they'll want to go and squirt those into a relational database at some point when you deploy the application. Now using something like Beanstalk, you can deploy your Rails or Django app to Git, you can do a Git push into Beanstalk, and then configure Beanstalk to run a common command in order to generate a relational database. So here for Rails it would be a rake command, and for Django it would be a syncdb. And automatically when you do your deployment, we'll create the relational database service, the RDMS, say a MySQL database, running under RDS behind the scenes to manage the data model for your app. So how do you create an app for AWS Elastic Beanstalk? What do you have to do then? Is it different from others? Well, it's just like any other application. In that, you can take a piece of code that you're running with locally on your local, let's say, LAMP stack. You're running with it, you upload that maybe via the AWS console, deploy it into the Elastic Beanstalk and run it. You can then download that very same source that has been pushed into S3, for example, on the Beanstalk, and then download that and pop that back into your local application, and it will run. There is absolutely no difference. You don't have to write to any specific APIs to make this work at all. So looking at packaging up would be done as normal. So look at the black lines there. I might have a Java WAR file that I've uploaded to the console. I produce maybe a Microsoft Web Deploy package from Visual Studio. Might have a zip file containing PHP or Python code. All of these can be pushed up into the console as an upload operation. But I've also got the ability to do things like use IDE plugins for Eclipse and Visual Studio, or to use things like Git integration to push from Git into my Beanstalk stack, and I'll show you some of those samples in a moment. So in the console you can upload a new version of an application, and this is a view of a Beanstalk that I'm running that's got various versions that have been deployed in the past, and I'm going to upload a new version. I simply click upload new version, and I'll be asked to choose the archive file to upload, and then I can choose an environment to push it to. So I could upload an application but not deploy it yet, and then choose to deploy that later, or I could deploy it straight into a running Beanstalk environment. That's a really simple way for you to manage your application and what's deployed into a Beanstalk. You can use command line tools and wizards as well, so you can script this stuff up maybe from Bash or something like that, in that you can check things like the application status, create an environment using classic command line tools, or you can use a nice wrapped up wizard called EB, where you can do an EB init and it will take you through all the steps required to create your application, just as you would do in the console. So you can create a load of automation around Beanstalk using those sorts of tools, but you can also create this as an environment for running you as a server from something like Eclipse. So this is an Eclipse IDE plugin where I can choose a Beanstalk environment. Here I've got Tomcat 6, but you can see I can support Tomcat 7 as well. Manually defining a server to run my app on. I can step through a wizard, choose the region that I'm going to run. I'm going to choose an SSH key pair to deploy. I can set some properties up for this then in terms of the application name and host. And ultimately it will be published into a Beanstalk, just like I could do within Visual Studio. So Visual Studio, again choosing Beanstalk as my new application template to deploy against, give it a name, step through some of the properties that I'd need to define, choose to run it on 2008 Windows, running IIS 7.5 on an instance type of micro, target runtime .NET version 4 here. Then I can run through, it's going to create an RDS database here, for example, for this app, so it's going to create some security groups for that. Summarize the properties, and then bingo, in a few minutes I've got an environment that's healthy and is running and is manageable from my Visual Studio environment. Now it's worth noting with something like this you can manage everything going on inside AWS, and the Visual Studio plugin is quite comprehensive. And you can see here that I can connect to an instance underneath my Beanstalk, I could rebuild the environment, I could terminate it, and so on and so forth. And there's the URL that this particular example app environment is deployed onto, and then you can map that using something like Route 53, and off you're going straight from the Visual Studio Developer Workbench. But if you're a Git user, shown here is deploying some PHP using a Git AWS push, and it's pushing and deltas out into my Elastic Beanstalk running in the EU West. And then it's completed and off I go. I've updated my application. Now the container itself you can configure in the console as well. So once you've got a Beanstalk running, you can have a look at things like the server that's deployed against, the load balancing and so on. So here I've got an EC2 instance I have T1 Micro running underneath the covers. I can set load balancer just like if I was creating an ELB by hand. I can choose things like application health check intervals, where the ping is going to be pushed to make sure these are healthy. I can set auto scaling rule, and here saying that min of 2, max of 4 across 2 availability zones. And then depending on the container there will be specific things about the container. So here putting environment properties out for Java, for example. But fundamentally you get the full admin access to all the underlying resources. So whether it be an EC2 instance you created, AMIs, auto-scaling groups, all of these can be inspected and changed if you want to. So we're not hiding any of the resources, all we're doing is managing them through Beanstalk Framework. And you don't pay for Beanstalk itself, you only pay for the resources created under the covers. So on the other end of that spectrum then, that's Elastic Beanstalk about high-level shrink-wrapped environments. If you want to get really fine-grained and declarative over the control that you assert across your cloud resources, CloudFormation is the tool to use. So if you think about what happens under the covers of Beanstalk, when you create an application and deploy it into Beanstalk, then a certain set of actions are going to happen inside AWS, like creating a security group, creating an auto-scaling policy, creating load balancers, adding instances, installing some software on those instances, and then consolidating the logs on a regular basis. And what Beanstalk is actually doing is it's marshalling a series of calls into AWS in order to create resources or configure resources. And it's calling into an underlying framework under the covers, which is enabling you to set up things like compute, scaling, databases, storage, load balancing, all the things that go on inside AWS is where CloudFormation wraps all of those as a framework in order to give you a standard sort of interface for creating resources, configuring those resources, but most importantly for the lifecycle managing of those resources using scripts. So the creation of resources, the destruction of those resources, the update of those resources based upon a templating or scripting language. The components that make up CloudFormation is the CloudFormation framework itself, and this deals with the creation of what we call stacks. So stacks on the right are what come out of CloudFormation, and these are a configured set of AWS resources where we have comprehensive support of the services in Amazon Web Services that you can use. It's customizable, it's event aware in that if things go wrong, it reports back to the CloudFormation framework. And then you drive that framework from a template, which is a JSON formatted file on the left. So you drop in a file which can have parameter definitions, so you can drive user-defined properties throughout these templates that ultimately create resources and then can perform configuration actions on those resources, all performed by the CloudFormation framework that has a transactionality with it, so that if some point of the stack doesn't create properly, you want to be sure that the whole thing rolls back and you don't end up with something that's broken. And we take care of all of that under the CloudFormation framework. So there's some snippets here that show how these template files work. So here's a parameter being defined, and I've shown the create stack template console UI at the bottom right. So if using a template with this snippet in it would drive this console UI for your users, and in this case it derives a parameter of key pair. So this is driving the key pair to use to enable SSH access for an instance that might be created. So I could type in the key pair name here, and then you capture that property, that parameter, and use it elsewhere in my scripts. Likewise, I could create a resource. So here I'm creating an RDS instance, and I'm creating a database instance of size M1 small of engine MySQL with a master username and password. Now they could have been properties that are parameters that I gathered using this previous example to drive the username and password. And then I can also configure resources. So here is a CloudFormation init using yum on a Linux instance to install MySQL, Apache, and PHP tools. So this creates a LAMP stack, essentially using yum on initialization of this instance using the script. But it also downloads some sources and unpacks some information into var.dub.html. So I'm going to S3 into a bucket to access a zip file to download my PHP application. So using this snippet, some point in the template will install the software that I need to install, and it will download some source. And just as easily, you might be diving into your HTTP config and editing the files, for example, using CloudFormation as well to configure the resources that are running. So the benefit of a templated environment is that it's procedural definition, right? So you can define stuff and remove humans from the loop. You can also create this programmatically. So think about a build cycle that generates CloudFormation templates out the back. So you might have a variant of your template for test, a variant of your template for load testing, a variant of your template for pre-production and production. So you can create these programmatically and alter these templates and then stick them into source control. They're parameter driven, so they're very flexible, they can be very dynamic in their nature, and ultimately they're just text files. So you can share templates with ease, they are just files, you can email them around, you can grab snippets off online communities and so on. And because of that text file nature and plain sort of JSON format, is that there are no configuration that you can actually source control. So you could generate these things programmatically, you could drop them into your source control platform, and have them associated with an application version. So if you need to roll back and recreate an environment for a particular app version, the template's all there in the source control. And you can diff your virtual data center even. Now, a company that's using CloudFormation heavily, and they used it recently for the Curiosity rover, is NASA JPL. So amongst a whole bunch of other services they were using to do some NASA TV streaming of the initial landing of the rover Curiosity on Mars. So live images that were pushed from the rover via deep space satellite networks all the way to NASA JPL were landing on their websites and ultimately on our desktops at the same time as the engineers were seeing it. And we were able to tune in to early images and early movies and so on. So how did they do that and handle the demand that came out to them? Exceptional demand for everyone tuning in to see this thing land. Well, they defined a template in CloudFormation, and their stack consisted of 100 plus server instances with load balancers, with DNS registrations. And this was to deal with their video caching infrastructure. And as they watched the load come in from different parts of the world, they used CloudFormation with one click to be able to deploy and choose where they deployed a unit of 100 plus servers anywhere in the world, choosing the region, the availability zone. And once the load subsided, they were able to then delete the stack and have those resources torn down. So one guy, one mouse, one click, deploying a complete stack of 100 plus servers in a few minutes and taking them away again when it was done. Okay, so transforming what was possible for these guys in terms of managing that amount of resources within the cloud. Now you can go and get more information. There's quite loads of snippets that I mentioned online, and there's loads of full stacks that you can go and have a look at that talk about everything from Windows Server and SharePoint through to configuring a DynamoDB table or setting up a WordPress instance, for example, an HA configuration. So if you go to CloudFormation/AWS CloudFormation templates, you'll find them there. But you can also download something called CloudFormer, which is an EC2 application that you can download and run in your account. And it'll have a look at what's in your account and your setup, your security groups, and all this sort of good stuff, and try and form a basis of a CloudFormation template, which you can then use to fill in the gaps on. So it's a useful tool if you've got a load of assets and you want to start going down this automation route. You don't want to start from scratch. Maybe this will give you some guidance on how to get to where you want to be. Now, the services support are comprehensive, so we're always adding the services that we release to CloudFormation so that you can template them up and wield them. So everything from setting up SNS subscriptions, Route 53 DNS records, setting up CloudWatch alarms, or even controlling who can do what using IAM. All of these things are there and supported above and beyond the good old sort of meat and bones, which is elastic load balancing, EC2, security groups, auto scaling, and that sort of stuff. But one thing to note is that CloudFormation also supports AWS Elastic Beanstalk, and this is where it brings these two together in an interesting way. Because if you go back to this sort of spectrum of high-level shrink-wrapped versus fine-grained declarative control, and we have Elastic Beanstalk at one end and CloudFormation at the other, they don't necessarily have to sit at two ends of the spectrum. They can sit close together, because with Elastic Beanstalk and CloudFormation, you can drive the Beanstalk with CloudFormation. So not only can you have nice little environments that have got high-level shrink-wrapped abstractions for your developers where they can work from their IDE workbench, but you can put those into a wider organizational context where everything is cloud-formed and controlled and templated. So you can create developer sandboxes that are ultimately production-ready infrastructure. They're templated in a way that is best practice, but you can still control comprehensively all the aspects of the infrastructure. So you can bring these two together in a nice way, and there's some smart things that you can do with both. But I mentioned also this middle ground, which is the latest addition to the AWS product family, which is AWS Opsworks. And this brings together the best of both worlds. It gives you a high-level abstraction in terms of managing application deployments and versions of applications, just like Beanstalk. But it also gives you the ability to dive under the covers and get fine-grained declarative control. So the components of Opsworks really start at a similar basis to CloudFormation, in that you have a stack, which is your managed environment. So this is a definition of environment, such as a production environment or a test environment. So a stack is then comprised of collections of resources which are organized into layers. So these are a blueprint of collection of resources that contain like EC2 instances with EBS volumes, elastic IPs associated, and so on. And you might have layers that support load balancing, application containers, database layers, and so on. We then have the application itself. So like Beanstalk, you deploy a package and it would deploy into your Beanstalk. Here we define an application and where those assets should be pulled from. In Beanstalk, you might have pushed it from Git. In Opsworks, you can also get from Git, but you can do things like SVN or download from S3. And then the application will ultimately be deployed into a container running in one of your app layers in your stack. We're also giving them the tools to manage scaling, cloning, how users can access these instances or not, properties like self-healing, which are slightly different to the way that Beanstalk and CloudFormation would describe resources. And these are the fundamental components in an Opsworks support. And under the covers, this is all driven with Chef. So Chef recipes drive the configuration of the assets in your layers and control the deployment of your applications. So classic layers, if you were producing a simple LAMP stack, would be load balancing, application container, and database layer. So at the bottom of the database layer, we have a MySQL database that you can define by default. We have application containers currently supported in there that are templated out, like static apps, Node.js, Rails apps, or PHP. And at the top, we have load balancing. And load balancing in Opsworks, unlike Elastic Beanstalk, which is using the Elastic Load Balancer, load balancing in Opsworks uses HA proxy to perform an installation of an HA proxy on an EC2 instance in an availability zone. So this kind of templated sort of architecture that we have here is that you would run an application stack that spanned availability zones, so that your HA proxy installation would occur in 3 availability zones, say, and then you would load balance using DNS like Route 53 across those 3 endpoints that were the route in, the proxy route into your application containers down below, where you'd have elastic resources that were growing and shrinking in each availability zone. Now you can of course define custom layers using Chef, but there's also layers like memcached that you can stick in front of your database, or you could stick a Ganglia layer in there as well. So you can extend these things, and we'll be adding to all these things as, more and more over time as defaults inside the console. Now auto-scaling and auto-healing are slightly different in Opsworks as they are to something like Elastic Beanstalk or CloudFormation. So auto-healing introduces the idea that you can have a number of resources running regardless of any scaling thresholds. So if you think about an auto-scaling group in Beanstalk or in classic AWS, you would set a minimum threshold. So let's say you had 3 availability zones in the EU West and you wanted to always maintain 1 instance in each availability zone. Here we would have 3 EC2 instances under Opsworks that were auto-healing enabled, and then would always be there regardless of what happened. In Beanstalk, if an instance were to fail any sort of fundamental health checks, the ELB would detect that, take that out of service. The auto-scaling group would replace that and bring it back into service behind the ELB, and this auto-healing achieves a similar goal. Then there are 2 different types of scaling that you can apply to instances under Opsworks. The first is you can create a time-based scaling for instance. So this would run an EC2 instance on a given schedule. So similar to setting up auto-scaling in AWS with a schedule where you can set to turn instances on and off given times of the day. Versus load-based scaling, where this will add or remove instances from a layer based upon some load rules, such as when CPU goes over 80%. So again, this is similar to a policy using CloudWatch to drive auto-scaling in classic EC2 or Beanstalk. So if you look at when you create an instance under Opsworks, you can choose the scaling type in addition to like the instance size, the availability zone, the region you're going to run in, and so on. So here we have a scaling type of 24/7, which will always be running. This will never go off. So this is where you'd add, for example, 24/7 instance with auto-healing, so it automatically kept replacing itself. And then we had time-based and load-based. So time-based and load-based example shots shown here. So load-based at the top, I've got a very simple rule here to scale up in units of 1 and scale down in 1. And scaling up if a threshold is exceeded for 50% CPU for greater than 1 minute. So this is a pretty aggressive rule and not something that would normally put in production. However, it will scale up aggressively and then it will ignore any other future events for 5 minutes after scaling up. So I can scale up aggressively using that rule. Scale down is slightly slower here, so I've got scale down in 1 if the threshold of less than 30% of CPU is achieved for 10 minutes. And then I'll ignore any other actions for 10 minutes. So scale up aggressively, scale down slowly. Simple load-based PHP app server rule here for my app. Time-based on this instance name here, I can set times, hours in the day where this instance will run versus not. So every day this instance will start at 7 AM and it will stop at 7 PM UTC. So I can set a time-based rule across the top of my instances as well, and I can mix and match all these different instance types. So I can have some that are 24/7, some that are load-based, some that are time-based, and as such I can layer up those sort of auto-scaling policies. When I get an app, I'm going to choose where I'm going to get it from. So I define an application type, and here I've got a PHP app that I might get from Git. Just as easily I could pull it from Subversion, or I could grab something, say, from S3. So I've got an S3 bundle here defined, which is a zip file of a PHP application sitting in my S3 bucket. And you provide your access key and secret key, and it'll go off to S3 and get it. And incidentally, that application there is the same one I've used in my EC2 masterclass demonstrations that are on YouTube if you want to go and grab it. You can then do deployment operations like deploy. You could undeploy an application. You could restart the web servers. All of these things surrounding the application tier of your simple application, in this case might defined as a PHP app. Now under the covers, all of this is running as chef recipes, and shown here are some of the default recipes for my PHP app layer. So I've got some maybe deploy recipes, there's deploy PHP that will go off and grab my resources from S3 and push them across any nodes that are running in the app tier. Likewise, I've got configure there that will go off and do mod PHP 5 setup on Apache, or go and configure some php.ini properties for this particular instance. And I've got my startup, deploys, shutdowns, and so on. The point is that you can go in and configure your cookbooks and add recipes to do any configuration you like. And rather than you go in and configuring via maybe traditional bootstrapping and user data on instances, you do it all via chef recipes here. So that's how you configure resources underneath AWS Opsworks. So in summary, it's all about getting started fast with Beanstalk and giving your developers a way to use a model environment but keep control of the chaos, because all of these are templated model environments. And you can take fine-grained control at the other end of the spectrum with CloudFormation, where you can create auditable environmental specs with these templates. And in the middle, we have the ability to manage layers of abstraction with recipes of Chef to be able to define more complex configuration and resources, so control with Chef customization using Opsworks. Now you can find out more at /beanstalk/cloudformation/Opsworks. There's a wealth of information in there, and in the user guides you'll often find getting started and sample applications, so you can get started and have a go with this stuff really easily, and you can have a go with it under the free tier. So things like Beanstalk, you don't pay for the underlying resources. So things like Beanstalk, you don't pay for the Beanstalk framework, you only pay for the underlying resources used. So if you're new and you haven't set up an account, you can set up an account, and for the first year you'll access a bunch of things inside AWS for free. So a great place to get started and try out some of those resources. So once again, thanks for joining me for this webinar, and see you all soon. So once again, thank you very much. As always, find out more at aws.amazon.com.